Hello everyone and welcome back to my channel. Today we're trying out something a bit different, which is I'm going to be talking about my research area today, which is machine learning. But I really hope that any of you guys that are coming from a non-mathematical or computer background, if you are watching along, that you can understand this, because I tried to make it understandable to a general audience. And if you are watching anyways, let me know in the comments below if you were able to follow along with this and if it made sense to you guys, because I'm always trying to make sure that research areas can be accessible to everyone, even if it's not your research area. So I'm doing a PhD in computer science, but my background is in maths and statistics, and that's how I came across machine learning. But some of you guys have been asking for me to do more machine learning and computer science videos, and that's not something I really saw about doing on this channel, but I did want to have it be more general PhD stuff. But to kind of try this out for this month, I want to do one sort of day a week on machine learning or computer science, programming, that kind of thing. One day a week on more general PhD stuff. So that might be writing or skills. So I've talked about transferable skills before, so it could be something like that. And then one day a week that's more on the personal side of doing a PhD. So things like routines, weekly or daily vlogs, which people have seemed to respond really well to, and things like, you know, financial aspects of being a PhD student, side hustles for students, all of that kind of thing. And then one day a week, that's all the planning, productivity stuff that tends to be what most people are interested in. So that's kind of the general plan. I'm going to have one of those each day and probably have one day of the study with me kind of videos as well. But it is a lot, so I'm going to be trying that out this month, seeing if it's something I can keep up with. But what will be really important to me is understanding what is working for you guys. So if there's a video style you like, be sure you are liking, be sure you are commenting below, and be sure you are subscribing, because that's what helps me understand which videos are working and which ones I should continue doing. So if you want me to continue doing one type of video, be sure you're engaging with that video type, or multiple video types if you love all the videos. If you want to see more videos about machine learning and my kind of research or PhD stuff in general, then be sure you do subscribe and that you hit the notification bell so that you know when new videos are out. So this first video is going to be an introduction to machine learning in general, just so that you guys have a general understanding. If anyone is learning about machine learning for the first time here, that you guys will have an understanding. And then in future weeks, we can get into some of the general algorithms, and then as well, I can show you the programming that goes alongside those things. But let me know if you'd rather see more general stuff or you'd rather see things that I specifically use in my research. So what is machine learning? So machine learning is a branch of artificial intelligence, which is a technique that enables machines to act similarly to humans. So trying to learn how to do things the same way that people do. And then machine learning is a branch of that, which uses statistical methods to enable machines to improve with experience. So they learn based on their own experience, or from the experience that's in the data, obviously. So machine learning is essentially applied statistics. So my background is in mathematics and statistics, and that's how I first learned about machine learning, was in my degree in statistics and in my master's in data analytics. So it's not 100% computer science, it is more statistics. You need kind of the mixture of statistics and computer science skills to be able to use machine learning. And then deep learning, I'm just going to mention briefly as well, is another subcategory of machine learning, and it's basically, it has the ability to work with a multi-layer network of algorithms, essentially, of different layers of things going on, and that's how it makes decisions. But before I get started with talking about data, I just want to mention briefly as well, I'm going to be talking about features to do with data. Everyone in school probably would have done some form of stats where you have different variables that are the input, and then you have one that's the output. So the features are the input variables. So one example I'm going to talk about later is housing prices. So the features might be the rooms, the number of rooms in the house, the number of bathrooms, the square footage, all of that stuff. And then the output variable will be the housing price that's associated. So just to mention that briefly as well. So I'm going to do some examples, and I thought, like, how could I make these examples a bit different if anybody is familiar with machine learning? So I decided to do things that are all based on YouTube. So here we see one of my videos. I'm actually wearing the same top, so that's kind of not ideal. Anyways, so one of the things that YouTube obviously employs was speech recognition, because you've got these captions that are auto-generated, and it says that there on the screen that they are auto-generated, meaning that I didn't provide the captions for this video. Instead, they use a speech recognition software that turns my speech into text, and that's automatically done. And it's not always 100%, obviously, especially when you have things like accents. Like, I do say that I recorded in English from Ireland, and then they obviously use some things. So, I mean, that part already looks like it's correct, so that's good. But that's one thing that they do. So that's an application of machine learning. And sometimes some of these examples are also going to be using deep learning, so it's hard to sort of separate the two, because you never know. Lots of things that can be done using pure machine learning algorithms can also be done or are done with deep learning algorithms. So the next thing that they do is spam classification. So you see on my comments, this is in YouTube Studio, but I have likely spam. So they know when a couple of comments are going to be spammy. So these are people who comment down below, sub for sub and things like that. So they get put into the likely spam, or they get held for review. And then I can go back and approve these comments. So sometimes comments that seem completely normal come up as spam for some reason. So it's not really 100%, but in Gmail, obviously you've got your spam, and that's pretty accurate. Like, I've rarely ever had anything in spam that's not spam. So yeah, so that's one thing that they do. That's done with machine learning as well. So they learn the difference between spam and not spam they have examples of ones that have been labeled by people who've said this is a spam email or this is a not spam email, and they learn how to categorize those as spam and not spam. Another thing that they do is text generation. So you can see I have this comment here from Eco Wanderer. Shout out to you for commenting on my video. Thank you so much. You contribute to my growth here on YouTube, so thank you. And so you can see that YouTube has started doing this in YouTube Studio, where you have generated comments that you can just reply. Now, I don't use those because obviously it's better to have longer comments if you want to get the engagement up, so it looks better in the algorithm, and it looks better for you guys if I'm doing longer comments and I'm engaging with you more when I can. So these are things that they do now, though. You can do automatically generated, and that will be, the machine learns how to understand the content of that comment and what would be an appropriate response based on previous interactions they've seen on YouTube. So they would have seen something similar to this on YouTube and had some people replying these kinds of comments, and that's how they learn, and that's how they come up with the responses. And the last example that I'm going to show to do with YouTube is recommender systems, and that's really what I work in, is recommender systems. And you'll know this from things like Netflix or Amazon, but as well, YouTube does recommend you videos, and your homepage will be a recommended thing, like a recommended set of videos that are specifically for you based on what you've watched before. And there's different ways that you can go about that. So if you want to hear more about recommender systems, that's my main research area. So that's the thing I know more about, of like different ways that they can work. So one way would be like people who liked this video also liked this video. And then another is, finding similarities between the videos themselves and not actually taking into account the human side of things. And then another thing would be taking into account people that are similar to you and finding what kind of videos they liked. So there's just a couple different ways. So if you want to hear more about recommender systems, let me know in the comments below. So now we're going to go into the types of learning algorithms, very basic introduction to these different learning algorithms, and just so that you have an understanding of the basic categories of machine learning. So supervised learning is the first one we're going to talk about. So the main two categories are supervised and unsupervised learning, but then there's also subcategories there like semi-supervised and self-supervised learning. I'm going to talk about those. And then there's also reinforcement learning. So I'm going to talk about all of these in this video. But supervised learning, basically what that means is you have a training data set with associated labels. So you essentially know the right answer in this situation. And these labels have been provided by a human supervisor. So somebody has labeled this data set. So I've got the example that I was talking about here. So we know the size of a house, we know the amenities, whether it's south facing or north facing, all of that kind of thing. And then the accompanying housing price was obtained from whenever the house was sold. So we have this training data, which is actual houses and the actual housing prices they sold at. And then we want to learn how to form the housing price based on the description. So we have a description and a solution, and we want to learn a general solution for when we have new descriptions but no solutions. So for example, we have a new house coming onto the market. We know all of the information, obviously. We know the number of rooms, number of bathrooms, all of that stuff. But obviously it hasn't gone to market. We don't know the price. But we can use the previous examples. We can train a model on this data to kind of come up with an estimate of the housing price based on the fact that we don't know, based on all the information we do know. So that's the general supervised problem, is we have training data with labels and we want to learn based on the training data features, what would the label be? One issue with supervised learning always is that it's very hard to find labeled data, and for problems that have a ton of different options, it can be hard to do. So for example, in speech recognition, there's an endless number of combinations of words that could be said. So to get somebody to come up with all of the possible sentences ever, that's not possible. And then having labels, so having the audio file and the accompanying labels, it's just so difficult to come up with all of that. So that's the problem with supervised learning, is it's not always possible to get this kind of labeled data. But then there are times like the housing prices that is definitely possible, because you would have things like that on record. And the good thing about modern times is that there's a ton of data being collected all the time by different apps and things like that. And in those circumstances, you often come up with a lot of labeled data naturally. So unsupervised learning then is we have training data and it doesn't have labels. So the goal here is to identify interesting structure in the data, because we don't know the answers necessarily. But you can see in the graph they have associated here, because unsupervised learning is something people don't grasp as easily, because you're kind of thinking, well, what would be the point of this? But one example is anomaly detection. So that's when you're trying to find something that's a complete outlier, and it's either something new or it's just, a total outlier. So you can see we have in the data, we have these clusters that we can see. And obviously in a 2D data set like this, it's very easy to see these clusters with your eyes, not necessarily using any kind of algorithm. So we can see we have these clusters of blue spots that are normal, and then we have these orange ones that are being classified as noise because they don't fit into these clusters. So those are the kinds of things you might want to look out for in a data set. And obviously you're saying, why do we need unsupervised algorithms if we can just see this? But in a multi-dimensional problem, so here we've just got two variables. If we have 50, you can't see this with your own eyes when there's outliers like that, but you can use an algorithm to cluster your data. And then if we have data points that are so far away from the center of a cluster, and a cluster is a group here, so you can see them in the graph as well. If we have something that's so far away from a cluster, then we know it's probably an outlier or something like that. So that's an example. Now we're going to go into the sort of subcategories here of supervised and unsupervised. So hopefully you have a general understanding of the difference here. Supervised, we have labels. Unsupervised, we don't. So the first example we're talking about is self-supervised learning. So we have an unlabeled data set, but actually what people do in these self-supervised learning is they actually turn an unlabeled data set into a labeled data set by manipulating the data in some way. So the basic task here is to find the missing part given one part. So to explain that better, we want to imagine if we have, like what we had before was a set of sentences. That was the data we were given. What the researcher does is they take out one part of that sentence and they generate this training data set with labels. So we have the information is the sentence with a piece missing, and the answer is the piece that's missing. So they train this way, and this way we have labels because we have the sentence with the piece missing and we have the missing piece. So they generate this labeled data set from unlabeled data. So it works in these kinds of situations. So in speech recognition, well, in sentence, like if you're trying to understand the semantics of sentences, you can take a sentence, remove one piece, and see if the system can learn to fill in the blanks. And similarly with images, we can take out a small part of the image and see can the system learn to fill in that missing part of the image. And actually it has been relatively pretty successful. You'd be surprised if you want to look up self-supervised learning. It is pretty interesting to see how a system can learn these things. And that's usually done with deep learning because it's not something a traditional machine learning algorithm can necessarily do by itself. Like a linear model is not going to do that. So yeah, we basically, in this sort of learning, you want to learn about the underlying properties of the data. And this would have required a lot more data if you don't do it this way. So this is kind of like the system's being thrown into the deep end, being expected to generate this missing piece from basic examples that they've seen before. So moving on, we have semi-supervised learning. So I mentioned before that labels are very hard to obtain, and especially in cases like speech recognition, web content classification. So if you've got a web page and you want to add tags to it, you know, it's very time consuming for a person to sit down and read through that entire web page and manually assign tags. And then as well, you probably have to have a couple of different people doing it so that they can, it's not like it's one person's bias, it's a few people who are collectively doing this. So it's very time consuming and it takes a lot of human resources to do all of that labeling. So semi-supervised learning algorithms have been developed for the cases where we only have a small amount of labeled data and a very small amount when there's a huge amount of data that could potentially be there. So when I said about sentences, there's unlimited possibilities for sentences, and we might have a small number of labeled audio to sentence files and a ton of audio data that hasn't been labeled. So basically this is used in any task that requires a big amount of human resources to do the labeling and when there's a big amount of possibilities. So the characteristics here are that we have a huge amount of unlabeled data. Otherwise we would just use a supervised learning algorithm. There's an input-output proximity symmetry. So what does that mean? It basically means that the underlying requirement here is that if two inputs are similar, their output should be similar. And that's a very simple thing to understand, but if it's not present, this won't work because you can't get the system to learn that two inputs that are similar should be very different. You know, this kind of algorithm wouldn't make sense in that way. So that's one other requirement. And another requirement is that the labeling should be relatively simple. So we need the labeling to be not more difficult if we have this middle step. So trying to get the labels from the small set of label data should not be more difficult than it would be if we had humans doing it. And as well, like generally we'd have this as a low dimension problem, meaning that there's not a ton of features, a ton of input variables and things like that. So the last one we're going to talk about is reinforcement learning. And this definitely could do with a whole other video all about reinforcement learning, but I just wanted to give a basic introduction to it because I think that's something people are usually trying to figure out, what's the difference between supervised, unsupervised and reinforcement learning. But basically this is a form of supervised learning because the main factor here is the system focuses on maximizing a reward signal. So the reward signal is the supervision that is accompanying it. So we have an agent, and it's set out into the feature space, so all of the input variable options are there, and it has to learn what actions it can take in this feature space in order to maximize the reward signal. So one example would be AI chess, or any form of AI game playing is generally done with reinforcement learning. So if you think about the chessboard, the bot, I guess, that's playing chess, it has all of these options of the different moves they can take, and the reward they're trying to maximize is winning the game. And that's all that really matters in this, is whether they win the game or not. So it'll play this game hundreds and hundreds of times until it learns what exact moves in what scenarios. So the environment also plays a role here. So you can see in the graph, you've got the agent, actions, environment. So here the agent would be the bot playing chess. The action will be a move that the bot takes. The environment is, in this case, we have somebody else playing chess. So the move that they take is the sort of environment that they need to relate to, as well as the chessboard that results from these actions. So when the bot makes a move, their piece is moved, so they need to update their understanding of the moves that are available based on the move that they've taken, and then again by the move that the other person has taken. And then, so the state will be the game, the board game, the layout of the board essentially. And the reward again will just be whether they're winning or not. Their probability of winning will probably be included in this in some way based on the layout of the board. And they learn by trial and error what is the best move to make in what situation. And there's also usually a delayed reward. So obviously in this case we have that there is the winning of the game. And that can be delayed in the sense that some moves that you take will have a knock-on effect on your probability of winning. So like if this game is tracking the probability of winning, your next move might not affect that necessarily, but it'll give you access to the move after, and that could increase by a lot. Another example is things like a bot that has to travel around and collect things. Obviously, every move that it takes won't necessarily collect something, but a few moves from there, if they continue along the right track, they'll pick up something, and that will be a reward. So the delayed reward is a big characteristic there. And then, because that's how it learns how this set of moves are important, as not just a single move, but like a series of moves. And then the trial by error is how it learns. And yeah, usually there'll be like hundreds and hundreds and thousands of instances of this, and then that's how they learn. So again, reinforcement learning can do its whole other video. I just wanted to give a basic introduction to all of these things. So I really hope that that was helpful for you guys. I hope you enjoyed this video, and if you want to see more videos like this, again, do be sure to give it a thumbs up and to comment down below, because this is a new style of video on this channel, and when we're trying out new things here, I need to know if they're working. So by you guys giving the video a thumbs up and commenting below, then that is a way for me to understand whether it's working or not. And then in future, that means I can sort of delve into the individual algorithms that you'll see in machine learning, and probably I'll do 1 week on the actual algorithm and explaining that, and then the following week on the coding element of it. You have time to kind of understand it before delving into the programming. So yeah, I really hope you enjoyed this video, and I will see you guys in the next one.